types of reactions, redox reactions. The first part is for reduction. The second part is for oxidation. So, electrons are transferred between elements. So if one gives them up, the other one has to take them. You can't have electrons just sitting around. They have to go somewhere. So you've got a giver and a taker. So there's a way to remember it. Leo, the lion, says grr. Leo, the lion, says grr. Loss of electrons is oxidation, Leo. Gain of electrons is reduction, grr. There is another one. Oil rig. Oil rig. Oxidation is loss. Reduction is gain. Okay. Now there's two species that are going to be on the left-hand side of a reaction, and they're called reducing agents and oxidizing agents. So they are the chemical that makes these happen. A reducing agent gets oxidized, and an oxidizing agent gets reduced. So it is an element. So what is the oxidation number on an element? 0. So what you're going to start doing is putting the oxidation numbers, the apparent charge, on your reactions right above. So, oxygen, what's its oxidation number going to be? What do you think, Spencer? 0, because it's an element. Now, you've got a compound. The oxidation number on oxygen we're going to do first. Oxygen is always going to be -2 unless it's a peroxide. And you would know that you have a peroxide because it will say peroxide in the name. Hydrogen peroxide. Okay? It will actually be included in the name. In that case, oxygen is -1. So, oxygen has an oxidation number of -2. What then is the oxidation number for magnesium? Anybody want to guess? It's +2. It's going to be the charge it normally is. So, group 1 metals, group 2 metals are always, their oxidation number is always going to be their charge number that they usually are. Where it's going to get tricky is when we have transition metals or halogens in polyatomic ions. Because you can have chlorine with a charge of an oxidation number of +7. Okay. So what you need to do, once you've labeled the oxidation numbers, is you need to identify who was oxidized, who was reduced. So when you have something being oxidized, it increases in the positive direction. It lost electrons, so it's got a more positive number. So oxygen went from 0 to +2. So did it gain or lose electrons? It lost. It lost 2 electrons. Therefore, magnesium is oxidized. Oxygen then gained 2 electrons. Therefore, it's reduced. And this is how we label an oxidation reduction equation. You identify the oxidation numbers, then you identify who gained and lost electrons, and you connect them with a line. You state how many were lost or gained, and whether it's oxidation or reduction. Okay. So your reducing agent is the item on the left that got oxidized, and then your oxidizing agent is what was reduced on the left-hand side. Let's do the next one. Let's do we're going to assign oxidation numbers to this compound. So what you're going to do is assign numbers for each element that's present in this compound. The name of this compound is sodium dichromate. Sodium dichromate. And that'll help. Plus 2 chromiums, whoops, bless you, plus 7 oxygens is equal to 0. So the sum of the oxidation numbers on each atoms will add up to the net charge on that formula. And the net charge on a compound is 0. So we've got 2 times +1 plus 2 chromiums plus 7 times -2 equals 0. So 2 chromiums minus 12 equals 0. So what is the charge? What is the oxidation number on chromium? 6 plus. So 2 chromium equals 12. Divides both sides by 2. Chromium is equal to +6. You okay with that? All right.
Where? No, this.
You move the 12 to the other side.
No, she was wondering, like, where
Oh,
it says-
how'd I get the 12?
No,
No.
-7.
Like, he thinks this was -7 beside the oxygen, but it's just 7.
Oh,
He
it's-
put the line completely.
Gotcha. Really? Okay. All right, you want to do another compound? Let's do... potassium permanganate. Potassium permanganate. If you have to do a redox titration next year, you're using this.
Did you watch Kim Jong-un and Donald Trump shake hands last night?
He's winning the Nobel Peace Prize.
Sorry, didn't mean to snort there.
Great throws, mate.
Oh no. Okay. What's the oxidation number on potassium? Because it's a group 1 metal. +1. Whoa, +1. Okay, what is the oxidation number on oxygen in permangate? Spencer. -2. So we've got to figure out potassium. Permanganate. Manganese. So potassium plus manganese plus 4 oxygens equals 0. So +1 plus Mn plus -8 equals 0. So your manganese has an oxidation number of +7. So this is just straight up algebra. All right, let's do a slightly different one. Perchlorate ion. Perchlorate ion. So now you're going to approach this the same way, except because this is an ion, it's not, the sum of the oxidation numbers isn't equal to 0. It's equal to the charge on the ion. So chlorine plus 4 oxygens equals -1. So chlorine plus -8 equals -1. Chlorine has an oxidation number of +7. You okay with that? Yes? Do you want to do another one? Or can we move on? Saeed? Move on. Okay. All right. Assign oxidation numbers. All right, Matt. What is the oxidation number on zinc on the left?
0.
0. Brock, what is the oxidation number on copper on the left?
For me, 2 minus, or 2 plus.
2 plus. It is the charge on the ion if it's just one ion. What is the oxidation number on the copper on the right? Tick. 0 because it's an element. And Lexus, what is the oxidation number on the zinc on the right? +2 because it's a single monoatomic ion. Okay. So identify for me who's oxidized, who's reduced. So we're going to put electrons on the right, and how many?
2.
2, because it gave up 2 electrons. When you write these reactions, the total charge on the left has to equal the total charge on the right. So if I add 2 positives and 2 negatives, I get 0, which happens to be the net charge on the left-hand side. So reduction, copper 2 plus is reduced to copper solid. Where do you think you're going to put the electrons? Matt,
The left side?
left side, you agree?
Yep.
Yep.
Big blank space.
And the big blank space is a big hint? And how many?
Solid 2.
A solid 2. Because it went from 2 plus to 0, so it had to have gained 2 electrons. You okay with that? Oxidation and reduction half cells. Half reactions. Okay, so now they'll cancel. So make sure you have the same number of electrons, and then they'll cancel. So when you add these 2 reactions up, you've got 2 Ks plus Cl2 goes to 2K plus 2Cl minus. Your electrons cancel. So when you have an oxidation and a reduction half reaction, if your electrons are on the same side, you've done something wrong, because they have to cancel.
Plus 8.
All right, what I want you to do is the questions on the back.